Aditya, are you okay?
No, I have no idea how to do this.
Okay, I cannot see. Please move. Okay, thank you very much. Right. Okay. So let me copy the question first. Put it in the Jamboard. Can you see it in page 5?
Yeah.
Okay. So Andrew, let me see. You okay? I'm gonna put Andrew's. Andrew, the pen is blocking. Please show me. 1, 4, 3, 6. Okay, now consider this, Andrew. Let me just speak to Andrew very quickly. How many H is on the left-hand side? Don't be muted, Andrew.
6.
How many H is on the right-hand side?
6.
No.
So no, it's 8. It's 3. Sorry, it's 2.
Now you probably need to rebalance, okay? You probably need to rebalance. Again, this is not the easiest thing to start with. So try to rebalance the rest, okay? Try to rebalance the rest. Yeah? Okay, now Aditya, I have to remind you of, this is probably a refresher, Aditya. Yeah? So the circle properties, okay, yeah? Look at me, yeah? I'll refresh very quick. This is called a perimeter angle. This is called a center angle, so to speak, okay?
Yeah.
This is neither. This is neither perimeter, neither center, and we don't care about these angles so much at the start. So let me give you an example. This angle at this angle here, that is neither perimeter nor center, and therefore we don't care so much, at least at first. Understand?
Okay.
This is perimeter. This is also perimeter. This is also perimeter. This is also there's a lot of perimeter here, right? Only one center. But please ignore the ones which are neither perimeter or center. So far so good, yeah? Okay, so we ignore. Andrew, you do a 3, 3. Okay. So Andrew, just to confirm, are you done or are you stuck?
Just give me a bit more time. I think I can do it.
This is however hard. Yeah? It's however hard. So you think about it. Right? So now, Aditya, very quickly, yeah. This is what you call a chord. Okay, I'm going to call this A and B. Okay. This center chord, this center angle has a chord AB. The chord is the imaginary line facing the angle. This perimeter angle has a chord, guess what? AB also. So far so good?
Yeah, I'm stuck.
B and this is C. So Andrew, let me give you something slightly easier. Slightly easier. So okay, that was the easier one. Try that one first. Now, yeah. So yeah, for the ACB and the AOB, the chord is AB. It is even written in their name. Angle ACB, angle AOB. Look, the chord is definitely the two ones on the left, on the right. But visually, this is what it looks like. You okay with me with the chord, Aditya? Aditya, okay? Can you hear me? Aditya, are you okay? Aditya, can you hear me, Aditya? Uh-oh. Aditya, can you hear? Aditya, can you hear me?
Yeah.
Yeah. Just now, you weren't responding. You weren't responding. Can you hear me?
Yeah, now I can.
Okay. All right. Okay. So Did you hear me what I say about the chord? Maybe the audio got some problem. Maybe.
No, I couldn't hear that.
I think the audio was a bit problematic just now. Yeah. So okay. AOB, the chord is AB. The chord is the invisible line facing the angle. ACB also have a chord. The chord is the invisible line facing the angle. And well, these two guys have the same chord. Look. Okay.
Okay.
Extremely important. If this is X, this is 2X. With the sole requirement that they have the same chord. One more time. There's only one requirement. They have the same chord. Let me give you another angle, which is also perimeter. All this D. Look at that. ADB have the same chord as ACB. Correct or not?
Yeah.
Angle D is, well, not X, but very conveniently 180 minus X. Okay. Last one. Let's call this AEB. Again, they have the same chord, isn't it?
Yeah.
This is now X. So let me repeat this one more time. Their relationship is dependent on the chord. They have to have the same chord. If they have the same chord, you have three criteria you can exploit. 30, 60, 30, 30, 30, 150. Is this okay? For example.
Yeah.
Okay, good. Try to implement that here first. This is already not the most basic question. Try, yeah. Now, Andrew, you must shift to the right a little bit so I can see. Yeah, the second guy, a little bit more. Thank you. Right. So, are you saying that you're done with the second guy with 1, 2, 1, 1? Am I correct? Is that it? Is that 1, 2, 1, 1? We are done.
Not yet done.
Let me show you how to do it. Now, let me show you how to do it in the fastest, bestest way. Right? Let's talk about the easy one. You must start with the guy which on the left hand side there is only one. On the right hand side there is only one. For example, sodium, only one on the left hand side. Sodium, only one on the right hand side. This is a very good place to start. Let me show you what is not a very good place to start. For example, you decided about oxygen. Oxygen is a very bad place to start because look, on the left-hand side, there are two things which contain oxygen. On the right-hand side, there are two things which contain oxygen. A very bad place to start. Do you understand me? Very confusing. Hydrogen. Is hydrogen a good place to start?
Yes.
No, because on the left-hand side, there are two substances with hydrogen. On the right-hand side, at least there's one. Yeah, but it's not very helpful still. So far, so good. We're going to start with the easiest thing. Let me show you. Aditya, are you currently still stuck?
Kind of. I still don't. I don't get it.
All right. So let me finish with do something else first. Do something else. That particular question, not a direct answer one, right? I think you are probably a bit rusty. I think judging from it. So do something else first. It's good, yeah. We found one rust. Now, Andrew, 2 and 1. Nobody will disagree. Can so far so good? Will this be okay, Andrew? Andrew?
Yes. Can you hear me?
Okay with 2 and 1. Are you okay with 2 and 1?
Yes.
Now, a bit of secret. SO4 can be treated as one package with the other SO4. So we pretend that this SO4 is separate from the oxygen. SO4 is treated as one package. So far, so good?
Okay.
We can do that. The SO4, only one package, one in left-hand side, one in right-hand side, making it a very good candidate. Looking at that, should we say this will also be 1? Make sense?
Okay.
Now we are at the final number, correct? We only have one more number here. The last number, therefore, no matter how easy or difficult, it will be easy. For example, I told you just now, the H is not a very good idea to start with. The O also a little bit confusing to start with, but this is already the final number. Final number, everything is going to be easy. Would you please give it a try for the final number? Oh dear. How's your translation, Aditya? Right? How's your transformation? Also rusty?
A bit like I've never like done something where, I mean, I might have, but I don't remember now. Where like I have to rewrite the equation.
Let's go back to the previous topic first then. Ken? Yeah.
Okay.
Let me show you how we will see things, right? We will see things, right? So remember, I told you the key is the chord. Now, for example, look at what they tell you. That's the important thing. Look at what they tell you. They tell you two angles, this guy and this guy. So far, so good?
Yeah.
Therefore, we pay attention to their respective chords. The 146, the chord is BD, correct?
Yeah.
For the 30-degree, the chord is the BA. Would you agree with me?
Yeah.
Taking 30, this is another, sorry, would you be, no, there isn't much that you can use with 30. Not right now, not right now. But let's look at 146. Look at 146, I immediately know that this guy has the same chord as 146, correct?
Yeah.
This guy is the X to X relationship. BAD is 146 divided by 2. Do you get that?
Yeah. Yeah.
Also, look at BCD. BCD is also having the same chord as 146.
Yeah.
Therefore, the relationship is, well, 2x and 180 minus x, meaning just go find the x first and then you just 180 minus x. So far, so good?
Yeah.
Any of them help you find ACD. What I'm trying to say is you probably cannot do ACD directly, but you can do a lot of things with 146. Maybe they will be helpful. Do you understand what I'm saying?
Yeah.
Do you already know how to find ACD then?
Yeah.
Okay, let's give it a try. Andrew, I take it that the H2O not very sure?
I think it's 2, the number. I write it down.
No. Okay, so you already know it is 2 or you are still doubtful?
I think it's 2.
You are correct. So how do we know? Well, the H will be 4 on the left-hand side and 4 on the right-hand side. Check the oxygen. Oxygen is 2 on the right-hand side and then 2 on the left-hand side. We are forgetting the SO4 because they are already balanced. So far, so good? Will this be okay, Andrew?
Yeah.
Look at me balancing the hardest one. Let's say that the middle reaction is very hard. It is not. Focus on the easy guy. What is the criteria of the easy guy? Andrew, is oxygen an easy guy? Is oxygen an easy guy?
Sorry?
Is oxygen an easy guy to balance first?
No, because there are 2
Very
on
good.
the other side.
Very good. Let's not do oxygen. Simple. Let's not just buy oxygen, right? Shall we balance C? Is C an easy guy?
Yes.
All right, then just the green line is just this is 1 and this is 3. There's no 6. No.
I'm sorry, I misread.
Yeah. 1 and 3. Would you agree? Now, hydrogen. Is hydrogen an easy guy?
Yeah.
Okay, right. Then therefore like that. So what is the number there? 3. Okay. Just like that, C is balanced and H is balanced. Simple, right? Just like that. We have the final number. Nobody said that the final number must be at the end, right? Now this is the number 2. Who cares, right? So now let's balance oxygen. It should be easy now. Tell me what's the number.
Well, there's like 5 oxygen on the other. Oh, sorry, not 5.
There are how many?
11.
The right hand side has no. The right hand
Oh,
side
sorry, 9.
9. Good. Now the left hand side must also have 9. So what do you do?
But it can't be 4.5.
You are absolutely right. And yet, first of all, mathematically is correct. Mathematically lah, mathematically is correct. Chemically is wrong because we cannot split oxygen 2. We cannot because they have a bond. Correct or not?
Yep.
The reason we cannot. Now you're correct. You are using chemistry. Chemistry say I cannot just anyhow split. Mathematically, however, I'm correct. What's the solution? Ayo, so simple, Andrew. Times 2.
2.
2, 9, 6, 6. Done. Happy one. You don't even have to check. You know it's correct.
Okay, got it.
So, if you to practice, I'll give you more in page 2. So, okay, please kindly try that. Then, I give you 2 reaction and do please balance. Now, Aditya, are you saying that the circle one still a bit confusing?
No, I get it. I get it.
Oh, you got it. Oh, you finished the question already, is it?
Yeah, I got 77.
Oh. You mean the question is only ACD? There's nothing else?
Yeah, that's it.
Oh, that was a short one. Yeah, okay. Okay, the revision is short. I think we refine another one. Now, do you need explanation for the translation?
I mean, it's 2 months, so there should be some working mark, right? I feel.
Surprisingly, when they say right, there isn't. Surprisingly.
See.
So when they say right, just give me the final answer. Okay, the working wouldn't count. Better be right though. Better be right. And I'm not sure whether to your surprise or not, but you are correct lah. Are you happy? You are correct.
Yeah, I guess I'm happy.
Right. Okay. Let's see what happened in the next question. But so far, warm up, so good. Now, Andrew, I like your video, but if you could just give me the answer in page 2, that would be nice also.
Wait, I haven't finished it yet.
Okay.
You do.
Remember easy guy, easy guy. Who's the easy guy? Aditya, do you like the minus in front of x squared? Yeah, you don't. Good. Yeah, handle it. Then handle it lah. You have the power to, change it, but you must change it properly. Let me see. And you will be wrong at this point when you times -1 on the left hand side. Am I correct? That's what you did, right?
Yeah.
When you do that, remember one thing about inequality. The inequality sign flips. Do you know why?
Oh, yeah.
Maybe your teacher teaches, oh, don't cancel everything. Okay, never mind. Yeah, but do you want to know why, or you just want to memorize?
I would like to know why.
Hey, the 18 is the 18. No, it is correct. It is correct. Okay. Now, you know why? It's something very simple. Look at page 6. This is 2 and this is 3. Please tell me, who's bigger?
Just a sec. Yeah.
Who's bigger?
3.
Right. Now, times -1 on both sides. Okay? Who's bigger?
-2.
Okay. Another one. 2 and -3. Who's bigger?
2. Yes.
Who's bigger?
3.
I'll show you 2 more scenario. You're gonna use your mouse to just answer it. Yeah. So go and check it out. And the last scenario is, well, just the same thing. Please just confirm that everything will flip. Andrew, again, I cannot follow your video. Yeah. Do you have an answer for either one? Yeah, it's gone again.
I'm almost done with the first one.
Good, good.
Is this correct?
Okay. Let me check. So Aditya, I cannot summarize it well, but I've shown you the proof that it will always fit. So to speak, okay?
Yeah.
Okay. Correct. At this point, you do have to remember it. So now for you, Andrew, your answer would be, I cannot see the left number. What is the left number? Andrew, your camera needs to be positioned a bit better. Yeah. Okay. Yeah, nice. Okay, thank you. So 1, 3, 3, 4, is it? 1, 3, 3, 4. Yeah. 1, 3, 3, 4. Okay, let's check. Okay, so is the C correct? Looks like it. Is the H correct? Looks like it. Now, is the O correct? On the right hand side, there is. Oh, check your O again. Are you sure they are correct? I think the C and H definitely lah, but the O. Now, Aditya, are you stuck here?
No.
All right. Seven. Oh, check again, Andrew. On the left hand side, 14O. On the right hand side, are you sure it's 14O?
Is it 5 or
Yep, I agree with you
10?
because 10 and 10, no? 10 and 10. Can yeah? Okay. Andrew, don't mute. So Andrew, this is not the easiest balancing lah. I hope you have some idea about it. Any questions so far?
No.
Okay, try the last one. Does the last one look very intimidating?
Let me take a look. Yeah.
Let's see whether it is actually harder than the first one. Let's see lah. Let's see. Give it a try. So this is still paper 1, right, Aditya? But you are at least doing all the good stuff. Yeah. How would you do this? Wait, just now you're correct. What? Oh, okay, I get it. You prefer that, sure. Accurate drawing, I like it. A labeling will be nice, right?
Okay.
The number.
I'll label after like
Sure.
after that I don't cover the numbers.
Good. Okay. Nice and accurate. Steady, good speed, very good. Aditya, no need to be faster, very good. Okay. Andrew, don't shift your book upward, yeah, but I'm requesting your camera to shift downward instead of your book upward, yeah, camera downward, better. So I can see the, nice, okay. So where do you start? You start from the H. I will agree with you, Andrew. Starting from the H seems like a good idea. Right, 3 and 2. Good. Right. Then who else is easy? Right? Who else is easy? Okay, I think you're deciding it this way, right? So
I'm not very sure now.
so let's check everything. If you want to be sure, we check everything, right? So first of all, the BA is correct, correct or not? The BA must be correct. Okay, BA happy.
Yep.
And the H seems okay so far. The H seems
It's okay. The problem's all
right. First of all, the PO4 also okay.
Mm.
The PO4 also okay, right? Okay. So what is the problem with O lah? Because the PO4 itself is fine. The O will be 3 on the right hand side, and 6. Okay, I see what you mean. 6, right? Okay, I understand. Oh, I know why you're wrong. No, I know why you're wrong. Because H is not a good idea. H is not a good idea to start. That's your problem. You know why?
Why is it not a good idea?
Because although there's one H on the right hand side, there are 2 H's on the left hand side. And that misleads.
Oh, okay.
That's the problem. So I would say you must not do the blue line. At least not until you clear all the easy guys. Okay. Clear the easy guys first lah. Right? Aditya, your drawing is fine so far. Are you stuck somewhere?
No.
Just normal. Okay. Right. So if the lines help you, Andrew, maybe you want to use pencil. But I mean, at the start, I would suggest using lines lah. They are very easy to do in exam anyway. Right. So are you going to use the PO4 or not? Are you going to use the PO4? Is the PO4 an easy guide to use?
Yes, I guess.
And use it. Use it.
It's 2.
Where is it 2? Yeah, good, 2, right? And then you suddenly have 3 numbers because you use all the easy guys. So now you can settle H and O more easily. Now.
Isn't it the same? Oh no, because you have this. So
just check first. Let me just check one time. Just to make sure that I didn't do anything wrong.
I finished the paper.
I'm sorry. You're saying sorry, Aditya?
I finished the paper.
Oh, paper 1, yeah. Okay. Nothing else is rusty. Let's try paper 2 and see what happened.
We did paper 2 last lesson.
Oh, we did. Oh, yeah. Then shall we do another paper just to be certain?
Yeah.
Yeah, everything is okay. I can confirm that your 231 is correct. Definitely correct, Andrew. What remains is just to finalize everything, right? Yeah, definitely. So whether you think about it in terms of H or O, you will be both correct, or rather you must be both correct. You must be.
Just a second. I got a paper.
You got, sorry, Aditya, you got what?
I have a question paper too.
You have a question, right? I'm sorry. Are you showing me something?
No, I have a question paper.
You have a questions paper. Okay, sure.
For like specific topics.
Oh yeah, sure.
So I'll do that.
Okay, sure thing.
Because I would have to print out another paper.
Oh, you want topical, you're doing topical stuff right now.
Yeah.
Sure thing, sure thing. This is chemistry. I guess I don't mind at all. Definitely. Andrew, I'm losing you, yeah? Shall we talk about this? I cannot see your video right now, yeah?
Mine?
No, Andrew's. Okay, Andrew, since I cannot follow you, do you want us to discuss this? Is Andrew suddenly gone? Oh, Andrew is suddenly gone, Aditya. Okay. Any questions, Aditya? Oh, no, that's just a revision. Yeah, there is a revision.
Yeah, I'm trying to properly staple this paper.
Right. I'm gonna make a call to Andrew, yeah? He might not even realize that he's out. Okay, yeah? Just a minute.
Oh, sorry. Computer died.
I thought you didn't realize that your computer is okay. Right, and your answer is 6, and 6 is correct. Are you okay with all this?
Yes, I'm more comfortable with it.
I gave you super hard questions. I mean, at the start, lah, right? But I also give you the way to solve them easily. Lah. Okay, aim for the easy guy. That has always been the case, lah, right? Okay, from the students that I encounter, I encounter students which the teacher doesn't seem to say that which order matters. You just do it randomly. You almost feel like that. You almost feel like that. Now, certainly there will be teachers who tell their students that the order is most important. Like you have to choose the easy one first, then you do the hard one. This is easy, this is hard. Okay. So I'm telling you all this in case your teacher and Aiden's teacher didn't say what kind of order is important. Right. I am preempting. right? Because I'm hearing complaints, I suppose, yeah, from both of you, right? Okay.
Okay.
The balancing is slightly more than this. That means intuition, we won't talk about the full thing because, well, first of all, we don't have a lot of time to talk about the full thing. I will, however, talk to you about the essentials so that when you pay attention in class, you'll be able to follow because at least you know the essentials. Okay? Right, yeah? Okay, so still pay attention in class, Andrew. Still do what they give you to do, then you will have a better understanding. That one is still true. Okay, now the balancing is over, and from now on, I will assume that you know how to balance because in the next topic, we will be balancing as our first step. Are you sure no more questions?
Oh, no.
Okay, now let's go to the next part. Aditya, okay? Aditya?
Yeah. Just rearranging. Yeah.
Okay, I can't really follow yet, but okay, if you put it like that. Okay, nice. Okay, so Andrew, in page 3, I'm going to now describe to you the mole chapter. The mole chapter is the continuation of the balancing. Rather, the balancing starts with mole. Okay, so what the heck is mole, right? Now, this is 2 molecules. This is 9 molecules. This is 3 molecules. Molecules is very long. Am I writing not very nice? I'm sorry, that's not 3, that's 6. And this is 6 molecules. Okay. 2966 doesn't sound like a very weird, does sound like a very weird number, but that's the only number that makes sense. Now, let me confirm, Andrew, what happens if I provide 2000 molecules here? Okay. How many molecules of O2 do I need?
Sorry, what do you mean by 2000 molecules of like what? Oxygen?
Okay. So I have 2000 molecules of C3H6, this one.
Okay.
Then how many molecules of oxygen do I need?
2000, the same one?
No. 2, 9. Isn't that what we established?
So,
2 molecules of C6 will react with 9 molecules of oxygen to give you 6 molecules of CO2 and 6 molecules of H2O. That is
9,000.
9,000. Simple, right? And that 2,000 and 9,000 will give me a total of
2,000, 9,000, 11,000.
Yeah, I know, but that will give me how many molecules of CO2 and how many molecules of H2O?
6,000 and 6,000.
Right. Almost trivial, right? Almost trivial. Please notice that, does this bother you? This is 11,000 and this is 12,000. Does that bother you? Does that bother you? You sure?
Yep.
Okay, because originally it's also 2 and 9 and 6 and 6. It's also 11 and 12. The number of molecules are never meant to be the same in both sides. They can be, but they need not be. Okay, so if I say that this is 6, if this is 6 trillion, Andrew, what is this and this? If this is 6 trillion, what is this, this and that?
2 trillion, 9 trillion, 6 trillion.
Okay, very easy lah. Once you get the 2966, right? Now let me test you on something. Remember when you say 9/2 is not allowed, right? It's not allowed, and you have a very good reason for it. The very was 1, 9/2, 3, and 3, right? Okay. Now my question is this: what if this is 9/2,000? Is this still not allowed?
No.
You mean allowed or not allowed? Sorry.
Allowed.
Allowed. And the reason is because?
Because if it's like 9 trillion.
Thousand, for example.
9,000.
9/2000.
Uh,
You no longer split a molecule, correct?
yeah, you no longer split it.
Very good. So now here's the basic thing that you must understand before we move on. If it is just single molecules, you cannot accept fraction because a molecule cannot be fraction. But in reality, nobody's going to tell you to take 2 molecules and 9 molecules, correct? Nobody. A very small amount of oxygen will already contain maybe million trillion of oxygen molecules. I mean, that's how small a molecule is. So in the case of many molecules, fraction is fine because you are not actually splitting a molecule, right? It's many molecule, a fraction is fine. Will this be okay? Okay, so now we need to extend that concept before we move on. Aditya, I don't see any movement. Are you okay or not?
Yeah. Yes.
All right. So now, for example, Andrew, I'm giving you another ugly number. Okay. For example, I give you 2/3 billion. Yeah. 2/3 billion molecules of CO2. Allowed or not?
Yes.
If it is allowed, you can give me the 3 other boxes. Please give me the 3 other boxes. Just be warned, they will not be pretty. You understand? They won't be, right? You have to learn to deal with or get used to ugly numbers before we move on.
2/3 billion.
For CO2, yes. So what's the what's the oxygen? What's the weird C3H6 one? What are they?
Will be 2/9 billion molecules for
First guy.
this guy.
Wonderful. I like that.
Then is 1 billion.
1. Wonderful.
Then 2/3 billion.
So this is definitely the closest, and you are correct. You know, I like. You can handle ugly numbers. Let me just show you what I will do. This is going to be 2/3 or the original one times 2/6. This will be 9/6 times 2/3. Both of them will give you this number. Excellent. Do you know why I do 9/6 and 2/6? Just to confirm. Andrew, I don't
know why.
Then how do you get 1? How do you get? I'm amazed that you get 1. You are correct, you know.
Sorry. But yeah, I did the same thing basically.
You did the same thing, correct?
Yeah,
then your 2/9 is also correct. Why? Well, you must be doing the same thing as me, right?
Yeah.
Now, this from now on, we will call this the molecular ratio, shorthand mole ratio. Okay? Molecular ratio, shorthand mole ratio. You are ratioing properly to get what you need.
Okay.
Where does the ratio come? From these numbers which we balance. The ratio comes from balancing, making sure everything is correct. Yeah? Now, give me a super ugly number.
Fraction.
No, even worse.
Number.
Decimals.
Okay. 3.36.
Oh, that's still not ugly enough. 3.71 will be the ugly.
Okay.
Okay? Work out the other three ugly numbers. However you can. Okay? I just lost your video, but yeah, if you have it.
Wait.
Oh no, I have your video. I lost Aditya's video now. Oh, now Aditya is gone. No, never mind. I'll just contact him. Okay. Today people are going.
Oh my God.
I mean, they are ugly, right? They are ugly. But you have
First
to.
number is 0.824.
0.82. Okay, I'll just move it to 824. Okay, wonderful. 3SF. Then
And the other two are 2.47.
2.47, 2.47. Now, from the way you do it, you seem to be doing it fast. Now, as long as you do it this way, this is 6/9 times 3.71. Did you do that? Is that what you did?
Sort of. No, for me, I just got the first number, then from the first number just times 3. So it's pretty simple.
From the first. Oh yeah, correct. No, of course you're correct. So the first guy, what do you do? Is it 2/9 times 3.71? Is that what you do? I mean, it looks about right, lah. It does look
something along that line.
Because you're doing it fast and you're doing it correct, I don't complain too much. I'm just telling you, even though it's ugly number, the ratio stays the same. The ratio is what matters, lah. The ugly number just follow, so to speak. Okay, yeah. And yeah. You're comfortable with balancing roughly. Andrew?
Yeah, comfortable.
I mean, what you mean by comfortable at this stage is that if I give you, an exam level question and you see this balancing question, at least you know what to do,
Yeah.
That's what I mean. Are you comfortable with the mole ratio thingy? Meaning, I'm able to calculate the other guy from just one guy, lah.
The mole ratio.
Yeah.
Still a bit new, I guess.
I'm sorry, you're saying? I'm sorry, what?
Still a bit new, I guess.
Definitely. The point is, remember, they give you one guy, they ask you for the other guys. They can do that.
Okay.
You roughly know what to do, lah. You roughly know what to do. Now, I'm explaining you the last part of basic mole, not the advanced part, just the last part. Okay. After all, the foundation is what matters. Okay. Now, please look at page 4. Okay. Still this same reaction, right? Okay. Now I'm going to reveal that this is a gas, right? This is a gas. This is also gas. This will be liquid. And this, surprisingly, will also be liquid. Okay. Now there's one more option. There's two more options called solid, solid and aqueous. So I'm going to just present them to you, which is supposed to be this guy. Yeah. At this point, you need to be sensitive to the state symbol, right? You need to know whether they are solid, liquid, gas, or aqueous lah. So you learn solubility a little bit. You may remember, you may forget. It's okay to forget. I just want to know how much you remember lah. Now, H3PO4, acid, base, or salt?
H3PO4.
Acid, base, or salt, or something else?
Wait. H3PO4.
Yeah, I'm sensing your acid, base, and salt. So okay, I'll tell you first that this is acid. How do
Acid.
I know? How do I know? How do I know? I'm not strictly
Hydrogen.
it because of the hydrogen, because every solid will have a H because it's actually a H plus. Every not every sorry, every never mind. In O level, every acid that you know, that's the H plus.
Okay.
Are the more popular acids that you know, right? Correct or not? Okay, so strictly speaking, identifying acid turns out to be rather easy from its chemical formula, right? So that's an acid. Now my question is, do they tell you acid is usually solid, liquid, gas, aqueous, or it's
Aqueous.
Yeah, correct. Okay. Aqueous. So far so good, right? So most of acids are, at least what you would worry about, mostly aqueous. Nice. How about BaOH2? What the heck is that? I'm going to call Aditya.
It is a hydroxide, so alkali.
It is an alkali, good. Now, did they tell you whether it's going to be soluble or insoluble, or you know what form might they be? Yes. Yeah, I realized that I lost you completely. Right. Okay. We have 15 minutes left. Do you want to continue? Oh dear. Okay, right. Okay. Send me your questions. Okay. Put it in the either WhatsApp. I'll at least answer using Jamboard. Right? At least get something more today. Okay. I'll see you in the WhatsApp. Bye. Okay. So taking turns to okay. Now, what do you think? BaOH2.
It's alkali.
It is, but and then you're absolutely right. Okay, but is it solid, liquid, aqueous, or gas? We need to be sensitive for a certain reason. So from the solubility table, they haven't told you about the solubilities of hydroxide, I guess. I'm guessing. Then let me tell you that most hydroxides are insoluble. Most.
Also bases.
Most well, it is true that most bases are insoluble. It is true, except for the group 1,1. So BaOH2 is no exception. Hey, it's a hydroxide. Oh, it's group 2. You can see periodic table group 2. Oh, this guy is insoluble one. Kind of easy to memorize. Okay. So if this is insoluble, what should I put? Solid, liquid, gas, aqueous?
Solid.
Solid. So far so good. I'll tell you later why this is important. Now, the salt link, barium phosphate link, if you have any, you might not know, so I'll tell you first. This is aqueous, and then H2O will be a liquid. Okay. Now we have 4 things: liquid, gas, aqueous, and solid. We are still at the mole territory. Yeah? So just now we work out, let's say, for example, 2 million molecule, 9 million molecule, 6 million molecule, 6 million molecule. Or in the other reaction, 2,000 this, 3,000 this, 1,000 this, and 6,000 this. Every other weird number, ugly number, you can also work out. Now, is it really normal for me to tell you this in the lab? In the lab, you know, you're doing all the practical camp stuff. Is it normal for me to tell you this? Andrew, go and get 2 million molecules of C3H6 and 9 million molecules of oxygen. Mix them up. Make sure you measure them well. Is that normal? What is not normal about my request?
You can't. It's very hard to get the number of that precise number of molecules. You just use like mules of stuff.
You just use what, sorry?
Use like other units of measurement.
Okay. You're saying that 2000 is too little, is it? Too difficult to measure? Okay, I'll say 2 trillion molecules and 9 trillion molecules. Is that better?
It's the molecules, because
The molecule is the problem. Okay, then tell me, how should I tell you?
I don't know, 2 milliliters of the acid. I don't know, something like that.
Milliliter will be a more preferable thing in lab. And you know what? I agree with you.
Yeah.
Milliliter. Now, how about gas? What do you usually say for that? You would rarely operate with gas. Volume, yes. So maybe from physics, what would you expect a gas to be measured with? Maybe, you're collecting gas in the chem lab and you will measure that by...
Measure that by
volume, volume, yeah.
volume.
Which is?
The volume is...
How about this?
Centimeters cube.
Or decimeter cube, sometimes depending on the situation. Okay? Hey, Andrew, go and take 20 centimeter cube of CO2 gas. That might seem doable. Yes? Normal?
Yes.
So there's milliliter and there's liter. I just got to put it there first. Liter, not liquid. Yeah. Now, how about solid? Take this amount of barium hydroxide. In what kind of unit?
Sorry?
Solid. Barium hydroxide.
Solid.
Yeah. Do I say to you, take 1 liter of barium hydroxide, which is, powdery solid.
Oh, wait, about mass.
Does that work?
Grams. Kilograms.
I will agree with you, by the way. I will agree. Gram and kilogram seems like a suitable unit for solid, right? Now, finally, aqueous stuff. So acid lah, acid lah, take this HCl. So how should we do this?
What HCl?
Taking acid lah, HCl. So how should I say to you?
Milliliters or liters?
Milliliter or liter. So milliliter of acid or liter of acid, definitely reasonable. Plus one more thing. Aqueous stuff can be strong, can be weak, meaning can be diluted.
Diluted.
Concentrated or diluted. Make sense? So you should ask me, hey, for our experiment later, Andrew, you will need to take half a liter of HCl. You should ask me which HCl? Is it the concentrated one or is it the diluted one? You understand what I'm saying?
Yeah.
So they will, in the label, they won't say concentrate or diluted. They'll give you the proper unit of concentration. What is the proper unit of concentration? It looks like this. Usually it is mole per dm cube. Might be a new thing here, but this is the concentration. So I should be saying to you, take half a liter of the HCl, concentration 0.1 mole per dm cube. Okay, that will be very concentrated and very strong, or a diluted one will be 0.001 mole per dm cube. Okay. I will specify to you 2 units. Will this be okay? The rest just 1.
Yeah.
Okay. Now, here is the most important question. I think, we see after. So, let's pretend for a while that everything here is solid. Let's just pretend for a while, okay? Just pretend for a while so that, make our life easier for now. Solid, I'll start from the solid. This is supposed to be 2, 9, 6, 6, right? Now, can I tell you something like this? Hey, go. 2966, right? You already balanced the equation, Andrew. Okay, good. So now you need to take, in this case, 50, okay, let's say easier. Okay, let's say 20 gram of C3H6, pretend that is a solid, and then 90 gram of oxygen. Is this the appropriate way?
No, it is not grams for oxygen.
I know it's supposed to be gas, right? Yeah, it's supposed to be gas. So I'm asking you to pretend that it is a solid. Just humor me for. Let's pretend that oxygen is solid.
Okay.
Can I say to you 20 gram of C3H6 and 90 gram of oxygen will be the right amount?
No,
Why not?
because it's one.
Sorry, what do you mean by one? Sorry.
That's fine. Sorry, could you restate the question again?
Okay, one more time. We know that I'm supposed to tell you something like this, okay? 2 trillion of, 2 trillion of C3H6 and 9 trillion of oxygen, right? That will be the right proportion to react, correct? Yeah. Because I want 6 trillion molecule of CO2 and 6 trillion of H2O. Let's pretend forward. So far so good.
Yeah.
So because I cannot say trillion molecule, that's very confusing in that. Then I switch instead of I say 20 gram and 90 gram. Okay, so that is not confusing. Maybe I'll change it to the appropriate unit. Yeah, you say that gas and liquid can use volume, right? Can use, right? Okay, so I'm going to do that. Okay, I'm going to say, hey, give me 90 milliliter and 20 milliliter. Would that be okay or not?
90 milliliters and 20 milliliters.
And 20 milliliter of C3H6. You tell me you complain about the trillion molecule. Okay, I change to ml, I don't know.
Yeah.
Be okay. Will this be okay or not?
I think so.
Right. Surprisingly, to us surprisingly, that is not true at all. I am supposed to explain why and then tell you what to do. Okay. You cannot just say 2 trillion molecule, 9 trillion molecule, correct, right? 29. So in milliliter also 29. Unfortunately, you cannot
calculate it.
You have to calculate something else because, for example, just give an example, a 90 milliliter of gas is definitely much less dense, right? Much less dense than 20 milliliter of a liquid. You know that a liquid is much denser than a gas.
Yes.
So 20 milliliter of C3H6 will contain molecule, in terms of molecule, so many more than 90 milliliter of oxygen. So many more, so many, like in the order of 10,000 or something like that. Because liquid and gas have different density. You cannot just 20 milli, 19 milli like that. Can you accept that? Do you understand what I'm saying right now?
Yeah, sort of. Like, as in, like, cannot have to use a method of calculation to get it.
Something like that. Something like that. Let me just test you a little bit more. Let's pretend for a while that I can use gram, okay? Can I use 2 gram and 9 gram? Can or not?
No.
But why not? I thought it's 9.
Oh, sorry.
I thought the ratio is 2 and 9. Why can't I just say 2 gram and 9 gram?
Because how to say, it's not accurate.
Okay, let me describe why in a little bit. Let's say, okay? So for example, let me show you the reason why. Never mind. At this point, if you know why, I think I should just give you the formula first, and then let's see whether it's confusing. Okay.
No formula.
Yeah. So the formula, the way to convert our natural units into molecules. Because only in molecule sense the ratio works, and unfortunately, the ratio is the true thing. The correct thing is the ratio. It must be 2 molecule with 9 molecule. I have to find a way to convert this liters, whatever, blah, 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 into molecules. I have to. Okay, that's just the need to do. And you will realize after a while, you will need to do this every time and every time, like just every time. Okay, which is why I say these topics are very foundational. Like you just have to get it. You just have to get it. Yeah. Now, let me first start with the solid one first. If I have, for example, I'll make you a simple one, a sodium. Okay, sodium. Na, I'll use your original. I'll use your original thing. I'll use your original reaction. Na plus HCl becomes what?
NaCl and H2.
This is a very nice reaction because you can see everything. So this will be 2, 2, 2, 1. Okay, Ken? This will be 2. This is aqueous. This also, I like this reaction. Gas, solid, liquid, and gas. Solid, gas, and aqueous. The liquid is the least important thing. I forgot to tell you. Liquid is very not important in O-level chemistry because, frankly speaking, there are very little liquid. There's a lot of aqueous and there's very little liquid. So the two liquids are Br2, which is liquid and gas, and then is Hg. We never use Hg. It's too poisonous. Okay. The only liquid you have to worry about is Br2, and sometimes it's gas somehow. Okay. So bromine, which is both liquid and gas, and
that brown gas something.
The brown gas liquid mix very smelly and
I saw on YouTube.
Yeah. Rather toxic.
Okay.
Cannot handle in lab. Very, can evaporate to gas and makes everybody sick, right? Makes everybody sick. But the color is the main attraction of Br2. You'll see why later. Other than Br2 liquid, you don't handle much liquid, you handle much aqueous. So let's not worry about the conversion of liquid. Let us worry about the conversion of solid, aqueous, and gas. Now solid. 2 grams of Na, I must find my MR. Do you know how to find the MR of Na? You don't have to memorize.
What is the MR?
MR or AR? You learn this in either term 1 or term 2? No?
Sorry, what does it stand for again?
Right, okay. Wait. Okay. We have time? Okay, this is the last thing I will show you, and then we go rest for now. Periodic table. Okay, so periodic table, yeah? I'm just giving you a truncated periodic table. Sorry, just a minute. Okay, please look at page 5. Okay, in your periodic table, oh, this is not a nice one. I'm so sorry. This is not a nice periodic table. I'm so sorry. They don't have the 2 numbers. This one is also not nice at all. Goodness me. Give me a nice periodic table, please. Oh, there you go. It's a nice one. Why so complicated? Sorry, I'm trying to find a simple periodic table. Why so complicated? There you go. That's a simple one. No, that's not. Oh my goodness, it's so difficult to find a nice one. I'm so sorry. It's so difficult to find a Z1. So I'm going to just create it for you, right? Okay. When you see a periodic table, look at page 5, right? I look at Na, right? I look at Na. Here's Na, right? Na has 2 numbers in your periodic table. It's 11 and 23. 11 is the proton number, right? 23 is the proton plus neutron number. Ever wonder why they don't just give you the neutron number? It's so annoying.
Why?
Because proton plus neutron is more important than neutron.
Oh, yeah.
Neutron is the weight. Therefore, this is what you call the MR or the AR.
Okay.
Now, for example, you want to calculate 2 grams of Na into how many molecules? It's so simple. It's so simple. You take the MR, which is 23. 2 grams of sodium is 2 over 23, what you will call mole. The word mole is not molecule. Something new.
Oh.
The word molecule is super many molecule. There's a standard to it. 6 times 6.02 times 10 to the 23. This is super many molecule. Some guy called Avogadro work it out into the magic number that we are supposed to use. I'm not telling you why that is the magic number, but that truly is the magic number. From now on, we use Avogadro's work to make our life easier. Instead of writing super many molecule or 6.02 times 10.3, we just use the shortcut mole, shorthand for super many molecules. Still molecules lah. Okay? When I have 2 grams of sodium, I use the MR, I will get my mole immediately. Okay, let's go back to the reaction beforehand. What does that mean? What does that mean to me? It's very simple. Come on, at least close here. Like we have to teach this, right? So that we're not too well, it's stable and so what does it mean for us? Then suddenly I have 2 over 23 mole here. Okay. It means now I know that the rest of them is 2 over 23 mole, 2 over 23 mole, and this one is 1 over 23 mole. Okay? It means I know that immediately. So far, so good, Andrew? Andrew, are you okay? Andrew, page 5? Is this
yeah, I think I'm good.
Okay. So if I have 2 over 23 mole coming from the 2 grams of sodium, 2 grams of sodium is quite a lot. If I react it with HCl, I will, for example, focus on hydrogen because that's what I want. I will produce 1 over 23 molecule. Many molecule of hydrogen gas. I will then, next one, tell you how to convert this to DMQ. Why? Because that is what the question will ask, and that is what your teacher will ask also in lab. In lab, you will also only measure the DMQ. So I need to convert this weird unit back to DMQ. That will be the end of my mole calculation.
Okay, so it's 2 grams.
2 grams of sodium becomes 2 over 23 mole of sodium.
Okay.
Which tells me hydrogen is 1 over 23 moles of hydrogen, which later on will tell me how many DMQ that is. Okay. Unfortunately, we do have to stop here because time is up. Okay, this is not done yet. Let me show you how it works. Maybe on Tuesday, maybe, I don't know. All right. Okay. Good job for today, Andrew. I will see you on Monday.
Bye.
Bye-bye. Yes, sayangku. Jadi done. What are you writing here? That is done, yeah? That is done. Let me just close first. Let me close.